So in our next video, we're going to be taking a look at how we can be more efficient in factoring x squared plus bx plus c. And we'll actually open up our definition a little bit for this trinomial here, because the c could be a negative number and b could be a negative number. So we'll take a look at how things would be impacted by having a negative sign somewhere in the problem. But first we start off with one that doesn't have any consideration with negatives. And that's just going to be a reminder of the whole idea of guess and check. So guessing and checking to factoring was the idea that if you have the sense that a trinomial factors, it's probably going to factor into a FOIL problem, let's call it. Two sets of parentheses, two binomials. And really the story is, if you can find the factors of C and you can guess a pair of factors of C. I think we saw an example where there's a 60 here, so we started putting two numbers here that multiplied to 60, and that would complete our guess. And then we had to FOIL out the guess. And we kept being satisfied with an x times an x matching very nicely with what we were trying to be equivalent to. And if we chose our factors well, we would take this number times this number as we were doing our lasts in FOIL, and we would always be very happy with that. But it was this middle number, this middle term, that was a bit of a problem because it came to us in two parts, our outer and our inner. So we would FOIL to make four terms, then we would combine our x terms, and we would check to see if our combined x terms matched nicely with this one. It works. So that big red X doesn't mean that this is wrong. It just means that it's not efficient. I think you do that a couple times and you start getting frustrated with how much time you're putting into just the idea of rewriting something. So we're going to try to ask you to be a little bit more efficient with it, and be more efficient as long as you are not losing sight of the reasoning behind it. So we'll give this a try, and if you're not comfortable at the end of this video, then go back to guess and check. But I think that over time, if you're thinking about it, you're going to gradually pick up some of the tricks suggested in here. So what's more efficient? What's going to be more efficient is we're going to very quickly try to think about all the pairs of factors of C. So we're going to think of all of the numbers that in that example we saw earlier multiplied to 60, and we're going to list them all, and we're not going to put together an expression like this, and we're not going to go through the trouble of foiling. We're just going to know that if we pick these factors correctly, the x squared and the c are going to be handled. We're just going to think about, well, if I add my outer term and my inner term, my x terms, are they going to add to make b? So a more efficient approach would be find the pairs of factors of c, and then identify the pair that adds to b. Now you've got your factored expression. So let's see what that looks like as an example. Our job is to factor x squared plus 11x plus 24. And again, no negatives to mess us up here. This is all going to be positives. So following our approach here, we're going to find all the factors of c, in this case 24. So looking at the 24, pairs of factors that come to mind. Well, one goes into every number, so we should probably get used to that. 1 and 24 are a possibility. A positive 1 times a positive 24 is one pairing that makes this positive 24 as an answer. We could also have a negative 1 and a negative 24 as a pair. Another pair of factors multiplied to this are a negative 1 and a negative 24. But if we're working on efficiency, we might want to take a quick second here and think about how that one isn't maybe a great guess and probably never really had a chance. Because if we're going to check to find the pair that adds to b, that adds to, in this case, positive 11, having two negative numbers and adding those together, you're never going to add two negative numbers together and get a positive. Negative 1 plus a negative 24 is going to make a bigger pile of negatives. It won't become a positive. So I think we should probably limit ourselves, as we're putting pairs of factors together, to the positive pairs of factors. So like 2 goes into 24, and you think about it, you divide, you use a calculator, whatever you need, and you figure out 2 and 12 are a pair of factors that make 24. They're worth looking at. 3 and 8 are another pair of factors. So we're going to keep going as we see this number in this column get larger, this number gets smaller, and eventually we'll get a signal that we're done with all of our pairs. But for now, I know 4 is a factor of 24 from our 4 times tables. It's 4 times 6. And these are getting really close to each other now. So we're probably running out. And if we think about a 5 doesn't go into 24. A 6, well, we already have 6. So we're done our factors here. And it's now time, we've got all the pairs of factors of C. Now we're going to identify the pair that adds to B. So if you're writing this out, if you're trying to explain it to someone, you say, now let's take a look at the sums. A lot of this will ultimately end up being in your head, and that's why you can get so efficient at it. But for now, the sum of +1 and +24 is a +25. The sum of -1 and -24, we know it's not +11, so we'll skip right over that. A +2 plus a +12, its sum is 14. So if we had set up a guess and check situation with these guys, our middle term would have been 14x, not 11x. We're not there yet. Our sum, 3 and 8, that's 11. That's going to be a good one for us. Now, this one down here, the sum's 11. So we found only one pair of numbers that works. And honestly, there will only ever be one pair of numbers that works. So once you found the numbers that work, that have they are a pair of factors of 24, and they add to 11 in this case, that tells you that when you go to write your factored expression, your two binomials, you want to make sure you get a +3 in there, and you're going to get a +8 in there. And if you did go through the check now, you'd be satisfied because your x squared is there, your 24 is there, but also 8x's and 3x's gets you your 11x's. So this is just a way to be organized. I would highly recommend writing it out for a little while until you get used to this, so you can really kind of drive home the idea to yourself. I need to find pairs of factors of C. I have to find their sums, and as soon as I find the sum that is 11, that pair of numbers belongs in our factored expression. We'll take a look at one more example, and this time we are going to bring negatives in. So in this case, the pairs of factors of C, well, we'll get to that in a second. We know that, again, this general form here with an x squared and x, a constant at the end, there's a great chance that it's going to factor as a two binomials. And the x and the x are going to satisfy this part. Moving on to the -48, thinking of the pairs of factors of -48. If we can find the pairs of factors of -48 and list them all, we hope to find one pair of factors that adds to -13. Now, a note. Pairs of factors of -48, you're going to have one positive, one negative. That's how you get a negative product. If they were both positives, we saw in the last example, the product would be positive. If we wrote two negative factors here, that product would be positive also. So pairs of factors of -48 will include one positive, one negative. For example, there's a decent pair. And there's a decent pair. Now, before I go much further, I want to think, wait a minute, this is going to be a long list. If we have to do one version of the positives or one version of the negatives, we could be here for a long time. So let's try to be really efficient here. When we think about the sum of these two numbers, these two pairs, it's going to give us an indication of how we can get more efficient. The sum of these guys is -47. The sum of these guys is +47. What ends up happening is, because these are different signs on these two factors, when you add, you get that canceling thing that goes on. But depending on how you assign a positive or negative, you can get a negative version of the 47 or a positive version of the 47. If you make the 48 the negative, they take over when you add, and you get a negative sum. If instead you made the positive the 48, well, then you get a positive sum. So to be efficient, what I'm going to do, when I write, let's see, 2 goes into 48. When I write the 2 and its pair of 24, I'm going to write it like this. I know I can do my positive, I can do my negative. I'll work that out later on. I'll look at those sums in a second. The sums of those guys are going to be some version of 22, because I'll either have two positives that cancel out two of these negatives and leave 22 negatives, or I'll have two negatives that would require positive 24 to make a product that we want. But when you add those together, you get a positive 22. So I can make a 22 of either kind. Let's see, 3 goes into 48. Back to our one video where 4 plus 8 is 12, and that's divisible by 3. So 3 goes in. We do some work. We grab a calculator, whatever we need to do. 3 and 16 are a factor pair for this, and we could make 13s. The sum of these numbers would be 13s of some kind. I know it feels like you're subtracting, but it really is a sum, because the canceling is what's happening there. Let's see, I think 4 goes into 48, and 6 goes into 48. The reason I sped up there was, if you were paying attention, we found the sum that we wanted. This 13 was exactly what we wanted to see. So I know that our numbers that are going to go into this factored expression are going to be a 3 and a 16 of some kind. Now let's think about what needs to be the positive, what needs to be the negative. If we know that when we do our outer product and our inner product, that they need to generate a -13 somehow, that means that we need to have more negatives than we do positives. Because when we add, we're going to feel some canceling. But when negatives remain, it's because the negative was the larger of the two numbers, leaving the positive here. So our factored expression then is x plus 3 times x minus 16. These two things are equivalent to each other. We just wrote this in factored form, and a factored form is just writing a multiplication problem. It's equivalent to what we were given. So now it's going to take some practice. There's really no new content for the rest of this week. We're going to show you another representation of this that might help you out tomorrow. But for now, we're just going to try to chip away at this. So your big ideas are factoring means writing something as a multiplication problem that's equivalent. When you have a trinomial that looks like this, you're going to have a factored expression that looks like this. And then maybe you're guessing and checking. Maybe you're getting more efficient. But our job is to try to write factored expressions that if we check them by foiling, we get back to where we were.